All right, Susie, let's see how this works. So what's going on is this is like how I start by teaching kids how to do quadrilateral proofs. I'm going to kind of walk you through the lesson the way I'd walk my students through, and I will do everything by flowcharts to hopefully you can see how I kind of develop the flowcharts in class. So if you have any questions, reach out to me, let me know, share this video if you like, that's cool. I'm always good with, everybody collaborates, everybody shares, we all have fun. Alrighty, so I start by telling kids, hey, these are the things that are true about parallelograms. We know that these 5 statements are true, and if we're given a parallelogram in a proof, we know that we can use all 5 of these things. If we're asked to prove a quadrilateral is a parallelogram, we only need to show that one of these 5 are true. It doesn't matter which one, but just show one of those 5 are true. So if we take a look at this first proof here, we're given ABCD as a parallelogram, and segment AP and QC are congruent. And we want to show or prove that those 2 segments, AC and PQ, bisect each other. So we always write down our givens first. So I'm given parallelogram ABCD. I put a box around my statement, and underneath my box, I put the reason why it's true. I know also that AP is congruent to QC, so that's given as well. So now let's kind of plan things out a little bit. I know that AP is congruent to QC, and what I want to show is that AC and PQ bisect each other. I know a bisector means it cuts things in half, so I really want to show that AR and CR are equal, and QR and PR. So I want to show these 2 triangles congruent. I need that green one. I didn't want to do that green one. Let's go back a little bit, and I want to show that this red one is congruent. So I'm going to ask myself now, if I get those 2 triangles, if I can get them congruent, what parts of the parallelogram are going to help me to do that? So what I hope the kids would say is that we have a pair of alternate interior angles that are congruent. So I'd like to show that this angle is congruent to that angle. And it's only true if the sides are parallel. Well, I know it's a parallelogram. So from here, I'll say that side AB is parallel to side CD, and that's true by the definition of what a parallelogram is. And because of that, I'll say that angle PAR is congruent to angle QCR. And the reason why that's true is because of what we call our AIA conjecture. The AIA conjecture for me says if 2 parallel lines are cut by transversal, alternate interior angles are congruent. I find the abbreviation works a little bit better for me. While we are there, if we want to, we can also say that the other alternate interior angles are congruent, the ones at vertex P and Q. Just to make it look a little different, I'm going to take the vertical angles in here that are congruent. So I'll start off with a new box altogether. Angle QRC is congruent to angle PRA. That's because vertical angles are congruent. And because these vertical angles being congruent doesn't depend on anything else, it's a box that can stand alone. It doesn't have to follow from something else like the one over here did, because this one over here had to follow from the parallels, which followed from the parallelogram. I got to put arrows leading up to it. So I tell my students that the goal is always get 3 pairs of parts congruent. So I have those 3 pairs of parts congruent. They show a triangle congruence. So triangle ARP is congruent to triangle CRQ. And its reason is angle, angle, side. And that's dependent on these 3 things occurring. So I have my triangles congruent by the 3 pairs of parts, so 3 arrows lead to the triangle congruence box. So now in my class, I allow them to say that if that bisectors create congruent segments. I don't really do the midpoint step. I understand those that do. I don't like to do it. So from here, the triangle's congruent, lead me to say that AR is congruent to CR. And because it's the same reason, I'll put the same statement in the box, and I'll say that PR is also congruent to QR. And all that is true by CPCTC. And therefore, since each of these pairs of segments are congruent, I can say that AC and PQ bisect each other. With my reason being the definition of bisector. So in my class, I tell students that a bisector divides a segment or an angle into two congruent angles, or two congruent segments. So I'll allow the definition of bisector to go here. So this is the setup of my quadrilateral proof using the flowchart method. I am kind of limited by the smartboard and things, but I do tell students working vertically is a little bit better than working horizontally. You tend to run out of room when you work horizontally on their paper, so working vertically on their paper works best. I'll keep going. If you feel good at any time, you can stop doing it or just like fast forward ahead. So another proof where I'm given a parallelogram, so I know that those 5 statements are true. I'm given some perpendiculars as well. So I start with parallelogram ABCD. There's my given. BY is perpendicular to AC. That's given. I could put both of these in the same thing, but I like to show them just a little bit separate because it helps kids to like keep them kind of separate from each other, to work on them singularly. Now, you might also know that I use the word show instead of prove. The textbook I use uses show, and I cut this out of the textbook. That's why. I always use prove otherwise. But I tell the kids in class, I use show, I use prove. It doesn't really matter. OK, so let's come up with that plan. Well, even before I begin, I'm going to write down something about my right angles. And because the diagram is marked that way, I'll use those right angles, and I'll use the triangles DAX, triangle BYC. So because BY is perpendicular to AC, I know that the measure of angle BYC is 90. And that's by my definition of perpendicular. Perpendicular lines make 90-degree angles. And I'll say the same thing over here, that the measure of angle DXA is 90 as well. Same reason, definition of perpendicular. And now I'll finish up those perpendiculars by saying that these two angles are congruent. Angle BYC is congruent to angle DXA. I like to say that all right angles are congruent. I've seen people say that congruent angles have the same measure. Whatever makes you happy, right? OK, so that gives me my right angle. So now I tell students, well, what else is true about that parallelogram? Well, we know in a parallelogram, we have opposite sides that are congruent. So one of the things I'll say, and let's see, I got an idea how this is going to work, so I'm going to try to sneak it in a little bit. That I'm going to go from here, and I'm going to say that AD is congruent to ADCB. And that's because in a parallelogram, opposite sides are congruent. So I got my right angles. I got those two sides. So next I'm going to work on my alternate interior angles like I did before to get those two. So the first thing I'll say is that because it's a parallelogram, I'll say that AD is parallel to CB. And that's what a parallelogram's definition is. And then that's going to lead me to my two angles being congruent. Let's just save a little bit of time and call that angle 1 and call that angle 2. So angle 1 is congruent to angle 2. Again, I have a big conjecture. I call it the parallel lines conjecture. That says that anytime parallel lines cut transversals or cut by transversals, that all the different types of angles are congruent. And then I break it up into 3 separate ones: alternate interiors, alternate exteriors. I abbreviate that AEA. And corresponding angles I call CA, the CA conjecture. So things are good here. I have my 3 pairs of congruent parts. Let's see, I'm going to make it a little bit easier to play with. So now I have triangle DXA congruent to triangle BYC. And I believe that was true by angle, angle, side. So here's one angle, here's my other angle, and here's my side. And then from there, DX is congruent to BY by CPCTC. Not too bad there. So earlier you might have said, well, what about the one pair of sides parallel and congruent conjecture as well, or theorem? I actually like to prove that because I want kids to realize that we use proof to do things that are helpful for us and not just prove things about figures. So I like to do this proof and say, hey, newsflash, look what happens. And also I try to stress to kids that, look, I'm given a quadrilateral, so I can't use any of those opposite sides parallel, opposite sides congruent, because I'm given a quadrilateral, I'm not given a parallelogram yet. So we'll start the same way. AB is parallel to CD. I know that AB is congruent to CD. These are both my given statements. I'm big on diagram recognition for kids as well. So a lot of my kids will say right away that side AC, we call it a shared side because the side AC is shared by 2 different triangles. And again, that's another standalone one. So I'll write that AC is congruent to CA, and I'll say that's by shared side. I don't say reflexive because I find that kids struggle with like the vocabulary words with it and stuff. My overall philosophy on proofs is that proofs are what makes kids hate math. And if I can make it a little bit easier for them to respond and to communicate mathematics, then I think I'm doing something good for them. I'm trying to help them to see that a little bit. All right, well, you've seen enough times to know what I'm going to do next now. Let's get a pair of alternate interior angles. Since AB is parallel to CD, I'll get those angles there. So what's that? That's angle BAC congruent to angle DCA. And that is true by the AIA conjecture. I now have a side angle side relationship. So we'll get these 3 coming together now. So triangle AB, or we'll do ACB, congruent to triangle. If we do ACB, we got to go CAD, right? And that's by side, angle, side. Now we're proving it's a parallelogram. So now I tell the students, well, what other parts of the triangle can we use to help us get, I'm going to go back a couple pages, boom, boom, boom. Oh, there we go. I got to get one of these true. What else can I use? And a lot of kids will see the opposite sides are congruent. So that's the direction I'm going to go in. I tell them we can go opposite sides parallel. That's fair. Opposite angles congruent. They say that. And I go, do you like doing angle addition? They say no. So we don't do that. And the other ones, diagonals bisect each other. Someone will always say that. And I go, how many diagonals do you see? And they'll go, oh, yeah, OK. So from here, let's say that side AD is congruent to side BC. And that's going to be by CPCTC. And then I'll say that we have a parallelogram because we have opposite sides congruent. And then I say, kids, wait, good things have occurred. Let's go back to the beginning, bing, bing, boom. And let's add in another one that says one pair of opposite sides. Sides has a D and not a B. both parallel and congruent. And I tell them that that's one of the Regents exam's favorite multiple choice questions to ask about, and we use it in proofs all the time, and they love it, and we love it, and we are all happy. And to put it right into play, boom, boom, here we go. The last one that we do here just shows right away that I've got a parallelogram. Well, I don't really have a parallelogram, I got a quadrilateral. And I say that. I say, do we have a parallelogram? And half the kids go, yeah. And I'll say, does it say it's a parallelogram? They'll go, no. And I'll say, but is it a parallelogram? They'll say, yeah. I'll say, all right, well then, let's say why it's a parallelogram. And I really point that out right there. So I say the first thing we're going to do is we're going to make it a parallelogram. So AD is congruent to CB. We'll say AD is parallel to CB. There's our givens. Given, given. And then right away, boom, they come together. And we say it's a parallelogram, ABCD. Why is it a parallelogram? It has one pair of sides, parallel and congruent. So now we got ourselves a parallelogram. I say, see how important that is? If you just pretend it's a parallelogram, you are like completely wrong. So you got to say it's a parallelogram first. And let's see, now we're going to finish this proof. What do we got? We got AJ and CK congruent. Let's write them down somewhere. All right, so what am I going to do? I got to do those parallels again? We'll skip the vertical angles. We'll do a bunch of parallel line stuff. So from here, we're going to say that, that's right, we got to say AB is parallel to CD by the definition of a parallelogram. And then from here, let's say that, and let's be lazy. Let's call that angle 1 and angle 2 and angle 3 and angle 4. And let's say that angle 1 is congruent to angle 2, angle 3 congruent to angle 4. Probably in class, I would break this up into two different things. But I think you know what you're doing. So then the triangles are congruent. Or the triangles, I can't even see it. Is it AJI? Okay. AJI congruent to triangle CKI. And that's going to be by ASA. And that gives me that, and all the way from the beginning, right? So that came over there. So you can see the arrows kind of get going a little bit. And then what we got to do? We got to prove I is the midpoint. Oh, we got to prove a midpoint. Lovely. So I is the midpoint of JK, okay? So IJ congruent to IK. And then from there, I is the midpoint of JK by the definition of midpoint. Cool. So that's the last proof I have. But just, I guess, a couple other things on proof as well, that, especially with the flowcharts. When I start teaching triangle proofs with flowcharts, probably like you, I teach the very, very basic proofs. You know, one where it's like, I'm giving you two things. There's a vertical angle, so it's side angle side, and that's it. So I tell kids that in every single proof, you're going to have this. Every single proof at some sort is going to look like this. So what you have here is you have some congruency, you have a congruency, and you have a congruency. And those three make your triangles congruent. And then you're probably going to have another congruency by CPCTC. I tell kids that's what you're going to have all the time. Let me just do something really quick. Let me pull all this and just move it all down a little bit. So you're always going to have that. Now, does that mean that before you might have something? Maybe you're given like a midpoint in here. Well, that's going to lead you to your thing. Maybe you have two other segments that are congruent, and you can do some addition to get that congruency in there. So there might be stuff that occurs beforehand, and after CPCTC, there might be other stuff too. Maybe you have like the definition of an isosceles triangle to get a triangle to be isosceles, or something like that. But I tell kids, way back when I start doing triangles, I said every single proof you do is going to have these 5 boxes. You're always going to start with those 5. After that, there could be stuff that comes before it, there could be stuff that comes after it. But that's like the basic gist. And even on my first test, I'll give a proof where I give them the boxes already filled in. You know, I'm gonna take a second. I'm gonna pull up like a test question that I've given. Let's see. Where is it? Where are my tests? Here we go. And it's gonna be probably. Let's see. Let's go to. I think it's gonna be right here. It's gonna be this test first. Nope. The one before it. So here's an example of like the first proof I might give them. And you see, I give them all the boxes already filled in. I kind of cut this out of my textbook. Very, 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 very basic. Just, hey, do you understand the flow of things? And then after they go through that, then I say, okay, now the gloves are off. And now do a proof, and you can write it up yourself as a paragraph or a flowchart. And let me show you a quick, I call them paragraph proofs, but they're really not paragraph proofs. I might write something that looks like this. Well, that's kind of bad, but I would say like by something, comma, something is true. That's more of like my answer key where I just throw things down. I hope all this helped you out. I hope you feel a little bit better about some of these quadrilateral proofs. Well, not the quadrilateral proofs, it's just the idea of the flow chart and kind of how it's organized. So if you got any other questions, let me know. If you want to take a look at like old tests that I've done or my answer keys and how I do things, I'll share them with you. If you have like Regents proofs, because I make up my Regents answer keys and I do them all by flow chart, so I can show you how those would be, you just let me know. All righty, it's good working with you. This was fun. I'll see you later.